All right, Charles' Law video. All right, here we go. Oh boy. I'm back. Here I am, video number 2. Back by popular demand. Charles' Law. Now, we talked about Charles' Law being the relationship between temperature and volume at a constant pressure. And we've already talked about Charles being on TV. TVC. Why would I say TV? Picture if you were yourself, if you're going to be asked to go on TV and you're excited, like say on The Price is Right, and they call you down to the bottom of the stage. Are you going to be miserable or are you going to be excited? You'd be like, yeah, raise the roof, I'm on TV. What? What's this on my wrist? Oh, TV. Why are my hands going up and down? Oh, it's a direct relationship. As temperature increases, so does the volume. Okay? This is a direct relationship. TV. I'm on TV. Yeah, raise the roof. Okay, that's just a way to remember that. Don't forget constant pressure. Remember the Boyle's Law? We said go PV. Inverse relationship. Okay? Charles' Law, TV, raise the roof. Okay. Up and down at the same time. It's a direct relationship. Let's focus on the calculations. Got the paper right here. You guys should be following along. I'm going to show you the first two problems, and then I'll give you the answers to the last 3. Okay? But then you do them yourself, and then we'll talk about them in class. Alright? So I'm not going to go through the whole thing because I'm still learning how to edit this video. Alright? So I'm doing the best I can. So first thing we're going to do is 4 boxes. Isn't this exciting? Oh boy, here we go. First box, second box, third box. We got 1, 2, 3, 4. Now as you know, in the first box we want to list our givens, the information in the problem. Second box we want to write the correct formula, okay, and show that we know how to solve for a certain variable. That's key, okay? Third box we want to plug it in. And then the fourth box we give an answer that is circled. Oh, remember last video? What was that little song I sang? What does it go? Oh yeah. Every number has a unit. Remember? Every number has a unit. Yeah, alright, now take a second. I'm going to sing it again now. You're going to repeat it after me in your house. I want you to sing this song. Every number has a unit. Yeah. Sing that right now. I'll wait right here. Okay, good. Very good. Okay, now here we go. So the first problem says, calculate the increase in temperature, circle that, when 3 liters, liters is a unit for volume, at 28 Celsius is expanded to 4.1 liters. So let's take a look at what we have and we'll talk about the Celsius to Kelvin conversion. Okay, so our V1 in this case is going to be 3.0 liters. Our first initial temperature they give me is 28 Celsius. Okay? We're going to do something here though, so just wait on that. I'll show you that in a second. Our second volume is 4.1 liters. Okay? And our second temperature is going to be our unknown. Okay? Because look at the problem. Calculate the increase in temperature when 3 liters at 28 Celsius is expanded to 4.1 liters. Okay, so we're going to find the final temperature. Now check it out though. We want Kelvin. Okay? And if you look at the top of your sheet, we have to convert to Kelvin. We talked about Kelvin in class. Okay? To get the Kelvin, you want to take your Celsius value and add 273 to it. Just like that. Just stick it right on that. And your value would be 301 Kelvin. Okay? So we got 301 Kelvin right here. So now we're ready to go. So the formula we use is V1 over T1 equals V2 over T2. Okay, cross multiplication, stuff you guys should already know. It's easy. So let's take a look here. We want to multiply these values, but we have one unknown. Our unknown is the T2 value. So hold on a second. These guys can come together. So you're going to wind up with T sub 1, V sub 2, divided by V sub 1, isolating our unknown T2 on this side over here. Okay? So right here is what we want to get from that. Okay? Be careful with that. Now, let's plug it in. Just like, what is that, Glade plug-in commercial? Plug it in, plug it in. Can't forget it, you know? Here we go. Plug it in. T2 equals, wait a second. I didn't give my shout out today. My shout out today could be to Mr. Rigner, assistant principal, 10th grade assistant principal. How you doing, coach? Coach, you'd be proud of me. Look at this, coach. I hope you get a chance to watch this, coach. Rock on, my man. Very good. Good job, Mr. Rigner. Here we go. T2, let's plug it in. Here we go. What's our T1 value? 301 Kelvin, which we talked about in class in terms of Kelvin, okay? Then we've got V2, which is 4.1 liters. Divided by, what's our V1 value? 3.0 liters. Okay, that's going to give us T2. Now, wait a second. Knowing what we know about Charles' law in the direct, hope you can see my wrist, direct relationship, if temperature goes up, so should volume, or down. Let's see where we're going so far. If I've got a V1 of 3 and a V2 of 4.1, volume's getting bigger. So our temperature should get larger also, okay? So when we calculate that through, where's my thing? Oh, here it is. When we calculate it through, 301 times 4.1 divided by 3 gives me approximately a T2 value of 411.3. I'm done. No, I'm not. I'm not done yet. What did I forget? Sing that song now. I'll wait. Every number has a unit. What's the unit, Kelvin? Don't forget your units, okay? I will take points off. If you don't have a unit, it's not correct, okay? You will lose points. When you go to the high school and you have these problems, be organized, okay? Show your work accordingly. Make sure you show your units. We're just trying to train you to be very detail-oriented in making sure you're showing your work correctly and accurately. Okay, so that's the first solution, okay? So I'm going to give you a second. I guess you want to look at that. There it is. Take a look. Hopefully you can see it good. Be patient. This is my second time doing this. Okay. All right? And there is nobody in this classroom, not even Siggins. Okay, I'm all by myself. Okay, we're good? Okay. I'm going to erase it. Hey, you know what? Hey, you sports people. Hey, you people that are doing all these sports and leaving my class 7th period. In this grade? See? See, we're always thinking here, how can we make things better? A lot of kids miss class because of sports. Well, at least this is something to help get you caught up. Okay? So when you have the other material to catch up on, it's not as cumbersome. Okay? So hopefully it helps you guys too. Alright, here we go. Second problem. 520 milliliters of air is at 41 Celsius. What is the volume at 65 Celsius? Okay. So, we have 520 milliliters as our first volume. And we'll keep it at milliliters this time, okay? Our first temperature is going to be 41 Celsius. Uh-oh, can't leave it like that. We'll come back. Our V2, what is? What is? What is? That means, what is it now? Be careful. You must read carefully and think. We'll keep that on as the unknown. Our T2 is, again, initially at 65 Celsius, okay? When I say initially, we're going to change that to Kelvin, all right? So let's convert to Kelvin. Add 273. Just stick that right in there. See that right there? And our value for that would be, what is it, 314 Kelvin, if I'm not mistaken. Okay? And right here, if I add this up, add 273 Kelvin, right? What do we get? What do we get? What does it say here? Man, I cannot... My rating is so sloppy. Up, 338. Here we go. 338 Kelvin. Okay? Uh-oh. So it looks like, knowing Charles' law again, direct relationship, okay? Unlike Boyle's law where it's inverse, if one value goes up, so should the other value. Alright, so let's do a little prediction here and see where we need to go. Again, you got to take your time on these problems. Okay? You must take your time in order to do them effectively. What do we have here? Temperature, 314. Initial temperature. Final temperature, 338. It's going up. So, geez, let me think. What should the volume do? Oh yeah, rise. Go up. So we should expect an increase. Just put a little note there so you know, okay? All right, let's make up the formula. V1 over T1 equals V2 over T2. Okay? Cross multiplication again. Keep in mind what you're solving for. You're solving for V2. Isolating that variable, okay? So you're going to cross multiply this and cross multiply this. Stick these two together. V1 T2 divided by T1 equals V2. Why is V2 over here? Again, that is our unknown. Is that clear? Okay? Questions? No? Write them down. Okay, good. All right, I'm sorry I said questions. I'm used to having people in here. Okay. Plug it in, plug it in. Here we go. What do we have here? What's our V1? Oh, 520 milliliters. Okay, neatly with the unit. What's next? 338 Kelvin. Where you at? T2, right? Yep, 338 Kelvin. You know what? Excuse me, my window's open. There's like a tractor out there or something. Hold on, let's close that window. I'm still here. Hold on. Woo! Okay. Back to this. So now we've got our V1 and T2 value divided by T1, 314 Kelvin. Equals, what is this? What are we solving for? V2. Okay, sorry, it's a little sloppy right there. Okay? And our final answer, if we take 520 times 520 times 338 divided by 314 Kelvin, we're looking at, let's see, we have a volume, V2 of 560 milliliters. Let's see if that's right. Let's check it and see. Let's see if we're on the right track here, if it follows Charles's law. V1 is 520. It better increase because our temperature went up. Again, direct relationship. So, 560, I think this looks pretty good. All right, let's hope it's right. Double check, okay guys? Always double check. All right, so those are the first two. It's the same concept. The only thing you have to be cognizant of, converting the Kelvin, just add 273. We talked about Kelvin in class, and if you're watching it tonight, we're going to talk about it tomorrow. Relax, I told you not to do these yet. I know some of you are though. Okay, but Kelvin, we'll talk about that tomorrow. Convert to there, and instead of P1, V1, and P2, V2, this is a cross multiplication type problem. Any other? Oh yeah. Let me give you the answer. I'm going to tell you the answers to the next three. Okay? So you might want to pause the video now and wait and do these three problems on your own. Okay? So pause the video. Okay. Now, here are the answers to the last three problems. Let's see. I'm looking at for number 3, I got approximately 541 Kelvin as my T1 value. Number 4, I'm looking at, let's see, the temperature dropped, so the volume should too. So I'm looking at a value of approximately 53 milliliters. 53 milliliters. And because you're solving for V2. And it looks like to me we are solving for T2 and number 5. And T2 gets us 239.4 Kelvin. Temperature seems like it dropped because the volume did also. So we're looking at 541 Kelvin for number 3. 4 is 53 milliliters. 5 is 239.4. Okay? So you check those, and if you have any questions, Science Help Desk, SSS, hey, there's no excuse. You have every opportunity to be successful here. One cool thing I do want to let you know about, besides just these calculations, we're going to start in Chapter 2, inviting other science teachers in here, and we're going to have some Science Help Desk on demand. So that's coming soon, I'm proud to announce. So have fun, and I'm done. Okay, bye. Well, I'm still here. Hold on, I got to turn it off.